Hello and welcome to this explanation video for my TCSI and remote internship. The internship I have done is on the forecasting system, which is to project the demand for the products at a retail outlet based on the historical data. I have used the Tableau.com dataset for the analysis and forecasting. So let's see what the time series analysis is. So time series analysis means a method for analyzing the data in order to extract meaningful statistics and other characteristics of the data. It is the forecasting to use the model to predict future values based on previous data. It is a sequence where a metric is recorded over regular time intervals. Means the data is stationary, it is a historical data, and we have to predict the data what the future sales or future demand will be like. So the frequency can be the yearly, quarterly, monthly, weekly, so on and up to even second wise. The P, D, and Q, where P stands for the AR term, and Q is the moving average term, and the D is the difference in required to make the time series stationary. So any time series data we are using for the forecasting, it has to be stationary. Means the standard deviation of the mean, which remains stationary or at a stagnant one throughout the time period. And if a time series has seasonal patterns, then it is called seasonal ARIMA. This is the Google Colab notebook I used for this project. And in the beginning, I have imported all the necessary libraries for the analysis of the forecasting and the stats models, pandas, numpy, and for visualization, I have used seaborn and matplotlib, and also the warnings which I might come across. I have imported that also. After the importing all libraries, I have loaded the Excel file I have used for this. The data I have used is the sample superstore data, which is available on tableau.com. It is a public data set, and we have to look on the column and the row data and get an idea of what the data contains. So it is the time series data. It is captured data from for a period of time. And about the shape of the data, it is 9994 rows and 21 columns. And df.info means the whatever the column is there in the data, we have to see what type of object it is. Means it is an integer or float, or it is a datetime. For time series analysis, we have to have order date the time series in the datetime format. And we have to find the correlation between any other entities with respect to sales to see if there is any correlation that might be related. So after the correlation, nothing is matching for the correlation, so we move ahead with the next process. Now we will index it with the order date, and timestamp we use it. It is the range from 2014 January 3rd to 2017 December 30th. These are the visualization I have used before the analysis. It is the sales from 2014 to 2018. Here in the mid 2014, it is highest sale over here, and next it is in 2016. Now we calculate the average mean sales data. Here MS means month start. So the data we have, it is showing here. It is made a sum of each month, and it is showed here. This is the graph for the average monthly sales data, where we can see in the mid of 2014 there is a highest sale, that is March 2014. Also on month to September 2014 and January 2015, and so on, show significant higher sales. These are the high peak points where we can see higher sales. So for this, we will be using the ARIMA model for the forecasting. And this is the bar graph for the yearly sales. This is the 2014, 15, 16, and 17, where we can see 2016 has the higher sales number. Now it is the data pre-processing. In the category, we are finding for the unique items in this. So how many categories are there? So there are furniture, office supplies, and technology. Only 3 are there. And we have to find whether there is any null values in all the columns in our data. So we have used isNA function for it. And as we can see, there is no null values. We can go ahead with it. And we have to search for all the column names to see which columns we need for the analysis. And I have created a list here named coal. And only we need the time series data and the sales data, only that, and category. Those are enough for our analysis. So I will be dropping all of these columns. And after dropping, when we find the shape of the data frame, it is 2 columns and 9994 rows. So as we have known, there are only 3 unique categories: furniture, office supplies, and technologies. We have to do 3 data frames for individual analysis of our time series data. So first one comes furniture data frame. here we created the data frame for it, for category equal to furniture. So here comes the order date as an index, and category and sales. The reason why we didn't drop the category in the first step means we have to separate the three categories, and afterwards we collect the sales data and drop the category column, so that it will be easy for the analysis. Now as we did, we drop the category column. Now it is this, and we sorting the values by order date. As we can see, it is the first most, means it is the January 2014 up to December 2017. Now it is a describe data, means it is a count, min, max, and the percentile values. The descriptive statistics. After indexing, we have to calculate the mean value and see for the visualize the data. As we can see, average sales is maximum at January 2015 for the furniture category, and this is a plot for the individual dates, and there are some peak points over here, so there is some seasonality. And I have plotted the box plot over here. This is the lower fence, this is the higher fence, this is the 25th percentile, 50th percentile, and 75th percentile, and there is only one outlier. Now there is a office supply data frame for it. It is the same process, so I will move ahead. Here the average monthly sales of office item, it definitely has some seasonality over in the March month. In this, it has three outliers for the office item. Now for the technology item, the monthly sales is at peak in the March 2014 and also in the October-November of 2016. And for this, the box plot, it has two outliers. Now we go for the seasonality determination. First is for the furniture category. This is the sales mean value, and this is the trend, and this is seasonal. Seasonal means there is a pattern here over the buying patterns, means sales. So the demand for the furniture was till 2015, and there is a decrease in here, and after the 2015, as we can see in the trend graph. Now for the office items, there is a trend and seasonality, and the demand is higher during earlier months of the year and lowest in the mid-year, and gradual increase in the demand at the end of the year. Now for the technology, it has very frequent seasonal pattern, and also the trend is increasing also. Demand was at peak in mid 2016, and downward trend follows for technology items. And I have explained for the stationarity before. So for validation of it, we will be using the augmented DF test, and for validating it, there should be p-value less than 0.05. Then we can reject the null hypothesis and conclude that it has stationarity. As we can see, there is p-value is less than 0.05, so we can reject the null hypothesis and confirm that it has stationarity data. And now autocorrelation and partial autocorrelation plots. Autocorrelation function at lag k, that is the correlation between series value and the k intervals apart, and partial autocorrelation function is same as ECF, but also accounting for the values of intervals in between. Now for the parameter selection for the ARIMA model, as I have already explained these parameters, we will move ahead. For the furniture, we will be dividing it into two parts for the analysis. First is for PMD ARIMA, where we use the train data for first from 2014 to 2015, and remaining data is for the test data, that is 2016 to 2017. For finding the best fitting model, we will rely on the AIC data, which can be used to determine which of the multiple models is most likely to be the best model for the given data set. Here it is a train data and test data, and approach one. It is the ARIMA model, and here it calculated the AIC, and here it is the PDQ and PDQ of the furniture data set, and we will be using these numbers for the fitting the model and also the forecasting. And here the model diagnostics. As we can see in the train data, the seasonal ARIMA model and the sales data is almost similar to this. There is a lag in between, but it is closer prediction. Now for the model evaluation, we have to calculate the mean squared error and root mean squared error and average for this. And I have used the ARIMA X function for it. Predicting the forecasting for the next 12 months. Here it is the sales data, and after this is the forecast that we have predicted, which means there is a decline trend, and it is not as same as it is less sales than the previous one. Also in this we have done the analysis till 2020 year, so this trend also continues, means not as the previous one but is a decline trend. Now there is approach 2 where we will be using the tested data for it. Here the AIC score is calculated. Here it is different, and next is fitting the model and the model diagnosis. Here it is almost in the normal distribution and it is uncorrelated. Now the visualizing forecasting. Here we can see there is a downward trend in the forecasting for the next years. Now we have to do the forecasting for the next 2 years, means 24 months. As also as predicted as before, there is a downward trend, which we can say the decrease in the demand. Now we move ahead with the office supplies. Here we create the trend data and the test data, and first we will use the ARIMA approach, where we use the EDF Fuller test and calculate the best model for the ARIMA by selecting the AIC score. Next we call upon the model and the diagnostics. Here it is a normal distribution, and also it is residuals are uncorrelated. Now we move ahead with the prediction. Here also it is a closer prediction to the original sales data. Here we can see there is an upward trend in the sales as predicted by the model. There is an upward trend. Now there is approach to calculating the lowest AIC score. Here it is 011 and 011. We use that number for the fitting the model and also the prediction also. As we can see from the graph, it shows the demand is increasing over the years with the upward trend. Now we move on with the technology category. We are training the model and testing the model with approach 1 with ARIMA, and it is, as you can see, it is not the normal distribution, and also there is a white noise, so we can't move ahead with the first approach. So we move ahead with approach 2, that is finding the lowest AIC score. Here the function has given the lowest AIC score. We use that to fit the model, and again now it is normal distributed, and we can move ahead with the prediction of it. Here the model shows there is a constant linearity. As we can see, there is a constant trend in sales for technology for the next 24 months. Now the forecasting is done. Now we compare the categories as which items are performing better compared to which. So we find out the shape of the data. Here it is only one column, and this much rows for these individual categories. And first we sort the values by order date for all the 3 categories, and group by order and order date and sales data, and resetting the index and indexing by the order date. And these mean we have already calculated at first. Here we got, this is the data frame for furniture, this is office and technology, and after that we will be merging for the categories that we want to compare, that is furniture and office, and technology, furniture and office. Here I have used the CBOR to visualize it. Here we can see the technology has the higher sales in the red line, and in the office supplies it is in the green line, so it is compared to it is very less, and in the furniture it is in the middle, and there is a peak in between. Let's move ahead. Here it is, and for the furniture and office it is visualized separately, and for furniture and technology, and for office and technology. After that visualization, it is evident that technology items is the higher selling product category, office items is comparatively less selling category in Superstore. Now we use the forecasting method using FP Profit library Here we are creating the data frame again with the DS. DS means date start, and there will be only two columns. Y data means it is a sales, and DS means date start. We have created the data frame here for the furniture, and we call the function for the profit, and we define it and predict the model. First we fit and see the data frame how it is, and it calculates the trend y hat and some additive terms. So we are mainly focused on three terms, which is y hat, upper and lower. So with the furniture data and slicing with only the columns which are required, we will move ahead with the visualizing. Here we can see the furniture item is it has some trend and seasonality, and it is growing state up to 2022. High sales is predicted on December 2018, August, September in 2019. Now we separate the components as like in sales and trend and seasonality by using Plotly. Here it is a sales graph. Here it is a trend. As we can see, it is upper trend, and in the seasonal, in the yearly sales data, in the month of November and December, it is the highest here. Now for the office supplies, we repeat the same again. We create the data frame and fit the model and predict the model, and slice only the y hat and y hat lower. And after visualization, this also is showing that is upper trending with seasonality. In the components of Plotly also, it is showing that it is the upper trend, and there is a seasonality in mid of January and lowest in the November. Now for the technology part, here it is the upper trend with a lot of ups and downs here. With the Plotly, we can see here it is also the upper trend. High seasonality is expected in the middle of October and mid January, and the lower seasonality on the middle of September is predicted. So from the FP Profit library, we can note that demand of office items is increasing as predicted from the above graphs. Trend of technology items linearly increasing over years, so demand of product is decreasing. Demand of furniture items is predicted as steadily increasing. And after seeing the ARIMA model and the FP Profit library forecasting, we can conclude that demand of office items is increasing as predicted by SRIMA model and FP Profit. Demand of furniture items is predicted as steadily increasing. Somewhat constant trend in sales for technology items is observed, but it have comparatively large amount of sales. Suitable business strategies have to be implemented to improve sales of product category furniture. That's it for my project, and I have concluded it.